Hello, everyone. We're going to be talking about the
vrpRouting project, and you get 2 people in this one for the price of 1.
I am Vicky from the pgRouting project, member of the PSC of pgRouting.
And I'm Josefa. I'm also on the PSC for pgRouting. Yeah.
Those are our avatars in GitHub, so you can look for us.
And pgRouting is on GitHub. It's github.com/pgRouting. So please fork and follow, or do the cool things.
So that's the link of the organization, and under the organization you will find vrpRouting, which is an open source project that it's a library for Postgres. It's an extension of Postgres. It's an extension of PostGIS. And it's part of the pgRouting organization.
Of which there's pgRouting, the workshops, which you see with the elephant with the hat, and vrpRouting. There's a pgRouting book. There is
OSM to pgRouting, and of course, pgRouting.
And today we're going to talk about vrpRouting, which solves sort of the vehicle routing problems in the Postgres database.
vrpRouting problems are NP-hard problems. There are optimization problems, and we're going to present a hypothetical problem that you can solve using vrpRouting functions.
Right, so if you have 4 individuals and they each want to get to different places from A to B, and you have a fleet of vehicles with different capacities and different constraints that can take these people.
But not only the people, maybe the people are sending packages. So and our fleet might not be taxis for transporting people, they can be trucks for transporting packages. Okay? So we are solving a general problem, transporting with several orders, or customers, using several vehicles.
Right, and each of these have some sort of a constraint. You have a pickup and drop-off schedule. Actually, the problem that vrpRouting solves are vrpRouting problems with time windows. And so you may have a pickup and drop-off time window for each person or thing that you have to deliver. And so it's optimizing the sort of routing problem under these constraints.
So those are the time windows from the point of view of the customer, okay? Not of the point of view of the software solution. When we want to do a software solution, we need to also consider the time windows for the vehicles that the user does not see. So you can see with these 3 different size vehicles, we have different brakes for the drivers. And if we are transporting people, then we need to shuffle to see what is the best vehicle, because the driver will take a break. Maybe that vehicle is not good because of the time windows of the user. Right.
And so, when you add a customer, maybe you want to talk about this slide because
let's start doing a solution for our original problem, transporting people, transporting packages. We have empty vehicles. That's part of the input. And we have this order represented by the person. And remember, it can be a package that it's sending, or it can be the person itself. But we're going to consider it as an order. And we put that input into vrpRouting, and it will spit us out the best vehicle for this problem. Okay?
Right, and then if you have multiple people...
Well, it's the next one.
Right, so you're adding another person, and so this optimization problem is growing, and now you have another constraint, and you need to pick up the second person and take them to another place. And so again, it's the same thing. It's just going to find the most optimal solution and or approximate to do this problem.
So you can see that the input of this second adding this customer is the output of the previous one. Okay? And it's moving the previous solution of the other customer to another truck. Why? Maybe because they fit in this larger truck. That's a possibility.
And so the problem grows if we have, add another customer, and we have this fleet of vehicles, and so it's this optimization problem, and it's going to move the customer that was previously in that vehicle before it's assigned before it departs assign it to a new vehicle and bring in this other customer because maybe the destinations are closer in this vehicle that we see on the bottom right.
So again, the input of the previous exercise, the output of the previous exercise is the input of this one. We're adding customers. It's like they are calling, maybe making a reservation. So we're adding gradually, and it's making the optimization gradually. This is the fourth customer of our original example. So maybe the optimization came out this way before the departure date. Okay? So vrpRouting has several functions. These functions that we're looking at here, VRP, compatible vehicles and compatible vehicles raw. The difference is that the functions that do not have the suffix raw, it uses Postgres timestamps.
And then you have a set of optimization problems. There's the VRP native optimize function, which I think Vicky can speak more on too, but then there's also sort of tabu-search heuristics that exist and other optimization methods.
So again, each of our functions will answer a question. In the previous one, compatible vehicles is I have an order into which vehicles it can fit if the vehicle is empty, basically. The optimize function is I have this bunch of orders, put them in, do not do the add one customer at a time, it's all of them on one go, and it will do the optimization. These functions, pick deliver raw, come from pgRouting, okay? And here are the ones that add a customer at a time. When you are preparing a bus for going from Auckland or an airplane from going to Auckland to Samoa.
And there are functions to describe the details of a route of a vehicle. So view route. It's been a while since I've done a lot of these ones.
So the output is given by the number of orders. So let's suppose that we have the 4 orders, and it goes for a one vehicle. It goes order 3, 4, 3, 4, which means the first 3 is the pickup, the second 3 is the drop-off of order 3, and so on. So it will, you just give the 3, 4, 3, 4, you will get the description of the times when it will be picked up, when it will be dropped off, the transportation time, how long does the bus have to wait for the customer. And we have a full simulation that is done on this VRP simulation. It simulates in a town in Japan, I think. Yeah. So we just got some aleatory data, aleatory times within 2019, I think. And it makes a full simulation of, in this case, I think, if I don't forget, it's transportation of people, so we're adding a customer at a time. So they make a reservation, and they want to go from one place to another.
Right.
What is next? The documentation. So if you try it, and if you want to collaborate with us, the first thing that we need to do is the documentation of these functions. The only functions that are documented are the ones that come from pgRouting, because it's the same documentation from pgRouting. So that is what is next in this vrpRouting.
Which is a fantastic way to learn the library, because you're going to build the documentation.
So you can download from the repository, which is in GitHub, on the pgRouting organization. And please keep routing.
Thank you, Vicky and Joseph. And does anyone have any questions?
No questions.
No questions?
We were very clear.
Yeah.
We have questions.
This might be a silly question, honestly. I'm not particularly familiar with pgRouting as a base. What does vrpRouting add to pgRouting that's different?
Okay.
Right here.
So pgRouting was originated to routing cars. I'm here, I want to go there. In here, vrpRouting is for vehicle routing problems per se. pgRouting evolved from, I'm here, I want to go there, because basically that was the only function that existed. It evolved to be graph algorithms. And this is optimization. You have several orders, several vehicles. How do I optimize this? And it's vehicle, basically, vehicle thing. And pgRouting is more graph thing. So on pgRouting, you can calculate the times. But on vrpRouting, you're going to calculate this optimization, but you're going to give us input the times or the transportation times between points. So it does not need necessarily pgRouting to be installed to be used or PostGIS to be used, but it's useful to have it because everything is related. Mm-hmm.
I was interested specifically in the optimization algorithm that you're using. I used to work somewhere that actually did this kind of problem, but they were using a genetic algorithm that kind of takes a guess, randomizes all the parameters and runs them through multiple times and keeps picking families of results that had good outcomes. Is it a similar algorithm or different?
We have different options for example, for initialization. Okay, how do I how do I calculate an initial solution? But we need to keep in mind that this is NP hard problems. So whatever the solution we're going to get, it's going to be a local optimization. It will be based on the initial solution. So when we are building like this transportation of people, because you made a reservation, you're not going to kick me out. Gradually, based on the order that the people get make the reservation, for example, you're starting with that initial solution, which is having this person there, a imaginary truck where the new order is, and you need to move this new order to the non-imaginary trucks. But you start with that initial solution. So when you're using this function where you're going to optimize a bunch at the same time, we have, I think, 7 different initial solutions given by time, given by, I don't remember, but it's like 7 different initial solutions. How I will fill the trucks, first order, boom, 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 until the truck becomes illegal. Then I remove the one that makes it illegal, put it in the next one. So we have different ways to start on different points to get to a probably different local optimization point. And we have taboo.
Yeah, so genetic algorithms not in one of those is not one of those heuristics, but taboo searches, and I think that over time there'll be more added.
Mm-hmm.
Anyone has other questions? No more questions?
Well, thank you very much for coming.
Thank you very much for Joseph and Vicky.